Hello. Hi, hi. Okay, so we're ready to start. Welcome. If you guys want water, you can go ahead. There's on the side, so you're welcome to take some. So today we're building a Twitter pager with an Arduino MKR. So you have those on your tables. The setup, well, the hardware setup is actually quite simple. So even though we don't have as many kids, you guys can pass it around, test your code on it. If you want to like unattach everything and then attach it again, that's totally fine. It won't take much time. The thing that we'll be doing a lot is coding, because we want to make sure that we understand how all the components work together, how they communicate, how they send data to each other, and then obviously how to connect the MKR to Wi-Fi, how to access the Twitter API, and then how to get data from Twitter. Okay? So this is our agenda for today. I don't know if you can see the screen very well, but it's literally just the intro. We're going to be testing it. We're going to go step by step to teach you guys how to do it. But before we begin with the workshop, I'd like to give you an introduction to who we are. So the Assembly, we are a smart lab and makerspace that we're based from in 5, and we were founded in 2014. So for the past 8 years, we've actually had 350 free workshops. And we do these workshops usually during the weekend, but then sometimes during the week. And we want to we focus on smart technology and practical applications. And the workshops that we do, there are 3 main categories. So we have hack, where we work with embedded systems, IoT, hardware devices like the Raspberry Pi and Arduinos that we're going to be working today. And for these workshops, we provide you with the hardware so you can test it out yourself. And then we have code workshops that focus on softwares, APIs, like frameworks, apps, and for these you only need your laptops because we're doing software stuff. And then we also have data science workshops where we focus on advanced topics like artificial intelligence and machine learning. But aside from that, we do workshops on so many different topics like cloud computing and robotics. We've also made sure to recently start with more like business and like entrepreneurial workshops to help startups, to help university students that want to go and like start opening up a startup. But yeah, our audience, it's students, it's professionals, it's entrepreneurs. Everyone from the community is welcome. You guys can come at any time that you want to come. You can follow us on social media platforms. We're Make Smart Things, which is also our mission statement. And you can find us on Twitter, on Facebook, Instagram, all that there is, really. And you can also see our website, theassembly.ae. We're also live streaming this workshop, so if you want to access our like YouTube page to follow along, you can do that as well. Now, for this, I've already pushed all the code examples that we're going to be working on onto Git. So you can open our GitHub page. It's the assembly. Well, I'll get it open for you in a second. So it's the assembly with an underscore on GitHub. Yeah. So it's this one. And you can go onto the site, so github.com/the-assembly. And then if you go down here, there's assembly Twitter pager. From here, there's 7 examples that we're going to be working on. The first one is very simple, so I didn't even put it onto here because it's like the default thing that we're going to be doing. But you can follow this to follow along, but I will also be typing it out with you. So you guys don't have to keep this open. This is just like if you're having bugs that you can't fix, you can obviously copy paste the code, but we'll also debug with you, so no worries. If you guys need me to open this later on, I will open it for you. It's just github.com / the-assembly, and it's the Twitter pager. Cool. Okay, so let's start with the introduction to what we're actually doing today. We're going to be working with these hardware components. So they have the MKR, which I'll introduce you to in a second. It's the Arduino MKR 1010. It has Wi-Fi and Bluetooth. Then we're working with an LCD, and we're working with, so I call it the I2C. I have recently found out that it's actually the I2C, so I've been mispronouncing it for a while. So if I make that mistake as we go along, just bear with me. It's spelled I2C. Then we're going to have a breadboard and some wires. There's also a cable that connects the MKR to your USB port, so you can connect it to your computer. But we're going to connect it together, so don't worry about it for now. The software that we're using is the Arduino IDE. Have you guys got it downloaded? Okay, cool. So most of you should have already downloaded it. If you don't have it downloaded, it's literally Arduino, IDE. And you can just go on it and just download it from this link. Just type Arduino IDE and download it if you don't have it downloaded already. Cool. Now, when it comes to Arduino, a lot of people think of the Arduino Uno, which is pictured on the left, or I suppose on your right, but we're actually using the Arduino MKR today, and I'll tell you the difference. So Arduino Uno, it's low cost, flexible, and it's an easy to use, programmable, open source microcontroller board. It works with many projects. It's kind of like a Raspberry Pi. And it's useful because it has a lot of shield compatibility. So on the picture on the bottom, that's actually the pictures of different shields that you can use. So there's touchpad, there's Ethernet, smoke detector, shield relay, and these are shields that you physically connect to your Arduino. The problem is there is no Bluetooth or Wi-Fi. So if you want to access that from your Arduino, you would have to connect it with the shield. Now, the Arduino MKR is a lot smaller, and it's designed for quick prototyping of Internet of Things or audio processing projects. So there's cloud connectivity, and the great thing is that you can record and interpret data with sensors and then upload it to the cloud right away as you go. So this has Wi-Fi and Bluetooth included in it, and that's what we're going to be using. Now, I know it might seem like the MKR is a lot smaller than the Arduino Uno, which means it's probably cheaper, but because it has Wi-Fi and Bluetooth built in, the price is actually quite similar. Okay, so let's start with testing the Arduino. First, you want to take it out of the box. You have it on your table. And, you can start one person at a time. What we're going to be doing is just connecting it to... You can do the GoPro view. Okay, cool. So we take it out. This is how it should look. You can keep it on this board because there's pins under it, so you can just keep it like that. Then you take out your USB wire. Oop. No. Yeah. This is the USB wire. You will connect the USB part to your computer. This other part, you'll be connecting it to your MKR board. Oop. So we're connecting it. There should be lights flickering, and that's how you know it's on. So there's a bit of orange flickering for a bit, and then there's a green light. So it's on. Now what you want to do is you want to open your Arduino IDE. So let me just close what I have open previously. We're going to open it together. So open up your application. For those of you that don't have it downloaded, just keep downloading it. But for those of you that do, open it up. So let's just go File, New. Okay, it doesn't cut off. Cool. Now, because we're using the MKR board, and this is the Arduino application, we need to make sure that the board is connected. So what we do is we go Tools, we go Board, Board Manager, and here you need to type MKR. Yeah, so do you have your Arduino IDE program opened? Okay, cool. So you open the program, go Tools, then you scroll down to where you see Board. Yeah, Tools, and then Board. Jay, do you want to help them out with this? So if you guys need help, if you're confused what's happening, put your hands up, and we have people that will walk around, help you guys out. You need help? Cool. Okay, so let's just wait a bit just to make sure everyone is on the same page. But once you type MKR, so Board Manager, type MKR, the first thing that comes up is Arduino SAMD boards. And you can see that the first thing that they have is Arduino MKR Wi-Fi 1010. So click Install. So I don't think you need to have it connected to download it. So just make sure it's downloaded because you'll connect it in a bit. Cool. Does everyone have it downloaded? Okay, awesome. So what we're going to do now is we're going to connect the port and the board. Because only one person at a time has it, we can just do it one at a time. So the first person, listen up, we're going to be connecting it to two things. First, you go Tools, you go Port, and you should have one that says Arduino MKR Wi-Fi 1010. It's still installing? Okay, let's just wait a bit for it to install. That's fine. Basically, because there's a lot of different boards that you can use, there's different types of Arduinos, you always need to make sure that the board and the port is the right one. Otherwise, it doesn't connect, the code doesn't run, and you're left very confused. That's fine. What's the next step after downloaded? Okay, so you just have to connect the board and the port, which is where I'm at right now. Okay, so for the other two tables, has it been installed? The person that has it connected? No, it's still installing. Has it installed for anyone else yet? Oh, really? It usually does it so quickly. Maybe it's the Wi-Fi. We'll wait then, just for a bit. Board. You can. Sorry? I'm sorry again? Oh yeah, the slides are also on GitHub. So the slides, the step-by-step, everything is pushed there already. So you have all the code examples, and then where you see README, you have the slides and you have the step-by-step. So go down to README. Give me a second, I'll show you. Change the, like, just remove the camera. Yeah, hide it. No, open it, hide the camera. Yeah, transition it. So here it's the step-by-step and then the PDF of the PowerPoint. Okay? Cool. Is it still downloading for all of you? Okay. Because whoever has it installed first, you guys can take the MKR and we can start like going further, okay? Hi, I'm so glad you came. How are you? You can just... Well, yeah, you can just come here. Come sit here. Has it installed for anyone on this table? Yeah, it's installed? Okay, cool, perfect. Guys, has it installed for anyone on this table? Cool. Installed for anyone? Yeah? Okay, cool. Okay, guys, listen up. I don't have a mic, so attention, everyone, please. I feel like I'm in a high school library, not even. And stuff. Can the third table listen up? Okay, I need your attention, please and thank you. So the person that has the MKR board installed, you can give them the MKR with the wire to them, and then everyone else just wait for yours to install because we're gonna continue with the steps. They're not difficult, it's very easy to follow, and like I've said, everything is pushed to Git, so you can open the PDF of the PowerPoint and you can open the step-by-step guide. So as soon as it downloads for you, you can do the same steps. Okay, so once the person that has it downloaded has it, go to port, and you should have a connection that says MKR Wi-Fi 1010. This is if you have your MKR connected to your computer. Okay? You don't have it? So on your port, you don't have the Wi-Fi 1010? Try disconnecting it and then reconnecting it again. Sometimes it takes a while to show up. Okay, and then for the board, what you should have is you go down to SAMD. This is what you just downloaded. And here you should have the MKR Wi-Fi 1010. The port will only show up if it's connected. Try it. Can you give them this cable? Huh? It was, so the person, I just gave you guys another cable. Give the MKR to that person, see if it connects, if the port shows up. It should show up, sometimes it just takes a bit longer. Do you guys have it connected? Yeah, does the port show? Yeah, and the board shows as well? Cool, okay, yeah, so it should show for everyone else. It just might take a bit. Yeah, so for port, it should show this port.
They can't see the port.
Try it, tell another person to try it. It might be that like it's just not loading, maybe the connection is bad. Or maybe give them another wire. There's no more here, but maybe you can bring from upstairs. Because there was like 4 here before. Yeah. Okay, cool. So Did it work for you guys? Did it connect? Cool. Did the third table connect? Does the port and the board show? Yeah, so it should have MKR 1010. Yeah, that's the correct one. And then here you go.
I already did that.
Yeah, perfect. It's connected. Okay, cool. So we can do the next step. This is just to make sure that the connection is working. We're gonna do the blink example, okay? So what you do now is you go, let's go back to where we were. You're at a new file, right? So you go File, Sketch, Examples, and then you go Basics, and then you go Blink. So Examples, Basic, Blink. Open Blink up. You can put the GoPro view. Cool. Now that you have your Blink example open, so this is a simple code. This is already generated. And what we usually do when we run code is we click the check mark to verify that the code is accurate. Technically, we don't have to do it in this case because this is already code that's been generated for us, so we know it's accurate. But it's a good practice to have because if there's bugs in your code, it will show them to you right away in this step. Now, once it says done compiling, you can upload it by pressing the arrow, okay? So upload it to your MKR. It will say that it's uploading. So this will work if you have it connected. So once it's done uploading, you can check, look at your MKR, and there's a yellow, LED blinking. Do you see the yellow LED blinking on your MKR? Cool, so that means it's connected, it's working. That's literally the first step of what we're doing. The MKR works, so we're good to go. Now, I'm gonna continue with the next steps. For those of you that wanna try this on your computer, you can just disconnect it and follow the same steps that we've been doing. So connect the port, connect the board, and then do the basic blink example to make sure that it's blinking like orange, yellow, okay? Cool. So that was the blink example. Now we can start with the setup for the hardware. Again, the person that already ran the blink example, you don't have to touch the MKR anymore. What we're gonna use is this. So this is what we're making. Easy setup. We're gonna take you step by step, okay? Cool. Okay, so everyone ready? So again, attention. I need like a flag. Okay, so one person can start off and then you can just disassemble it and assemble it again. So take your breadboards. We're gonna connect the LCD to it, okay? So what we're gonna do is we're gonna place the breadboard down. We're gonna see where the empty pins are. And then you're gonna, connect it like that. So you're gonna just connect it. Make sure it's in a straight line. Sometimes the pins won't go fully in and that's okay. It's just too long. Don't try to push it because it might break the pin. You don't wanna break the pin, okay? So this is the connection. This is what we're doing. Cool. Now that we have this connected, we can connect the I squared C, which I call the I2C. Yeah. So this is what we're connecting next. What we want to do is we want to align the pins of this to the pins of the LCD. The LCD is 16:2, so we want to make sure that it's aligned together. Oh my God, my professor came in. Hi, Mr. Judy. Hi, Algo. Yeah, sorry, a little detour from assembling this. But okay, so we take it, and we will align it exactly where it is, and I can't see that well, so I'm gonna lift it up. Yeah. So you're gonna put in all the pins down together in a straight line. So you want to make sure the LCD is in one straight line, all the pins entered together. Check the breadboard. Sometimes there might be pins stuck from like a previous thing, which is also why you have to be careful when you take the LCD out. So you don't want the pins to break. You want to plug it in so the pins of both the I2C and the LCD are closer together. Okay? And make sure it's aligned. So this is how it should look. Does everyone have this? I'm gonna go around and check. Hi, you guys got it connected? Oh, we'll take the wires step by step, it's fine. But if you guys know what it is, then it's okay. Hi.
Yeah. What about uploading? How can we not?
So you know that it's uploaded because you click the plus sign to verify, and then you click this to
I
upload.
already did that.
You did? So you see how it's blinking?
Yeah.
That's the blink code. Now you know it's connected, now you know it's working. This is just the first step. So if it's blinking, that means the MKR is connected, it's working. We can do the next step, which is the hardware. Okay? Cool. Do you guys have it? Okay, you're connecting it? Cool. Connected but not blinking? So did you upload it? Oh, it's still uploading? Yeah, it might take a while. In some cases, if it like takes a really long time, you might want to close your Arduino IDE and then open it again. Sometimes there's just errors. So we're still here. We've connected the LCD and the I2C. And now we're gonna use our wires. So you should have 4 wires on your table. Usually in practice, it's better to start with connecting ground. The reason you're doing this is because right now, we're not connecting it to the MKR directly, or maybe it's disconnected, which is good. You want to connect ground first so that it doesn't break. If you connect power first, then it might explode. Obviously, it won't be a big explosion, but it'll break the MKR, it'll break the devices you're using. Don't want to do that. So, okay, let's connect ground. Ground is the first pin. You can see it on your I2C. It says G and D. Yeah. So right here, you can see on the screen, it will say G and D. You know it's ground. Okay? Yeah. So now that you have ground connected, what you can do is you can connect it to your MKR. How you know where ground is it says it on this side. So lift up your MKR. It has ground, so G and D for ground. And that is where you connect your first wire. So ground. Now we're gonna skip the second wire. You can put it into the I2C, but you don't want to plug it into your MKR right now. So just keep it plugged in, don't plug it into your MKR. Then we're gonna connect the next 2. So you've connected ground into your pin. Skip the second one, we're gonna go to the data line, okay? Data line is the 3rd wire connected to your I2C. And then again, check where your MKR has SDA and connect it there. So SDA, we're connecting it here. And now the 4th and last wire is the clock connection. So you connect it to your I2C, and then check where your MKR says SCL and connect the wire there. So SCL. Any color, just as long as you pay attention to it. Technically, in practice, ground is usually black, power is red. but it's fine as long as you know what wires are doing what. Cool, and now that you've got the 3 wires connected, you can finally connect power. It's connected from VCC to 5 volts on the MKR. So where you see 5 volts is where you connect power. So once you connect power, your LCD should light up. So I'm actually going to disconnect it and let everyone else try this as well. Do you guys want a second one so you can practice?
Yeah, sure.
And then, like, since when you guys don't need it anymore, I'll just give it to another table. Like, if you want to connect it, disconnect it. So this will be connected to the MKR, but you can disconnect everything there and, like, rewire it if that's what you want. Thing is, a lot of the times it gets stuck, so you want to be able to take it out, put it in.
Structure just for our understanding.
So, okay. Well, technically, what happens is you don't need this I2C. You can connect it fully with wires, but that will require like 16 wires. Soldering would be better, but let's say even if you solder everything, even if it's all in place, if one of the wires isn't working, your whole thing won't work. And then you won't know which wire it is because there's 16 wires. This makes it a lot easier because then you only have 4 wires to connect. So if there's a faulty wire, you can literally just remove all 4 to connect 4 new ones. So yeah, easier to do it this way.
What's this one?
So this is what does like the communication between the LCD and the MKR.
No,
That's why.
People.
Oh, this, I don't know. That is a good question to ask the manufacturer.
Ask the manufacturer what.
Where the little thingy is. That's fine. Hi. Yeah, so what happens is the second wire is power. And if you connect power first, it can cause like everything. Yeah, you don't want to short circuit it. Like a little tiny explosion. You wouldn't even notice it. But it would break the components and then you can't use them again.
Yeah.
But once you connect everything, so you've connected the SCL, correct, SDA, now you can connect power. So, sorry, I'm a little like, it's my first. Usually I'm the one streaming the workshops. This is the first time me giving the workshops. So you connect it to 5. Yeah, and it lights up. So, did it connect? Okay, so it lit up for you guys as well? Cool. Okay, so everyone has it connected? Yes, perfect. So now, because we need to include a lot of libraries in our code. So we're gonna start with, okay, I will just connect it again. But you know how I said we're using the I²C? We technically don't need to use it. So what happens is, instead of using this one like model thing, you can technically use 16 wires. Using 16 wires is a little frustrating because you need a bunch of different connections. It also means if one wire isn't working, it could stop everything from working, and you don't want that. This makes it a lot more simpler. You only have 4 wires. But now you need to make sure that you actually have the communication, and you need to see what this device number is in order to run code with it. So we're going to be downloading a library for it. So we can do that together. We can go back to our Blink example and then go File, New. So the Blink example was the first example we're doing. That's why it's not on GitHub. It wasn't very necessary for us to do. The second example, though, is scanning for the device. And this we're only doing because we'll need it in the next few codes that we're going to be running. And technically, so you can find the code to this online. I didn't create this code, but we're going to be working and typing it out together. Oops. Cool. So the first thing you want to go is Sketch, include library, go all the way down, and include wire. Does everyone have wire? Okay, cool. So we're going to include it. So this library basically allows you to communicate with the I2C device, and it lets you reach to the data line pin and then the clock line, which is what we've connected. Then we're going to have to... So we're using it because that's what allows you to communicate with this I2C, and it lets you connect with like all the pins. So we're using the data line, we're using the clock line, and this allows this communication. So libraries have a lot of things built in with them, so it's just easier for coders because we don't have to build it from scratch. Cool. So now, I don't know how familiar you guys are with coding, but there is a void setup and then a void loop function. So setup is only run, like it only runs one time. It runs at the start of the code and then never again. So the things that you put into it will only work once, and then that's it. Then the void loop works like every time. So you run the code and then it keeps looping through it. So that's how you know what to put in what section. Okay, cool. So we want to start up, since we included this library, we want to start it. We want to make sure that it's initialized, that it begins. So how we do that is type wire.begin. So this is to initialize it, and it joins the I2C bus as like a controller or like a peripheral, basically. Now, yeah. Now, for this code, we're going to use serial monitor. It's this little like section on the top right corner. So we need to make that work as well. So let's type serial.begin. And then here we're going to give a value 9,600. And I'm going to explain what this does. So you want to start your serial communication. That's with the serial monitor. And it basically, the Arduino can send commands through the USB connection. And the serial port is capable of transferring a maximum of 9,600 bits per second. So the 9,600 is called a baud rate. I'm not sure if I'm pronouncing that correctly, but it's B-A-U-D rate for the connection. And it's basically how fast the data is being sent. So it can only handle a certain amount, and that's why we're passing 9,600. Okay. So now we're going to have a while loop, but it's only going to be used to check whether the serial connection, like whether the serial port is working. Oops. So while it's not serial, so while there is no connection, it'll stay in that loop. Because if there's no connection, there's no point going out of that loop. None of the code is going to work, and we need it. But after that, we can... Sorry? Oh. Can you guys see that better? Wait. You want me to like move it around? Okay, give me this. Well, now you can't see it at all. I tricked y'all. Oops. So I'm just going to close the other code that we don't need. Okay. You guys can see it now? Cool. So while there is no serial connection, it's going to stay in that loop. But if there is serial connection, we need to make sure that we know that it's connected. And we're going to do that by just giving ourselves a message. So we're going to say serial.print, or we can do println, so there's a new line. And then we can type, so forward, like this /n is like for a new line. And then we're going to type what we want it to say, and we're going to say like the I2C scanner, because this is what we're going to be doing. We're going to be scanning for the I2C. Don't forget that semicolons are necessary in C. This isn't Python, so if your code doesn't run, it might be because you're missing a semicolon. We don't want to have that issue. Now, yeah? It will continue running if the connection is not working. If serial port isn't connected. Because basically we need serial port for this code, and if there is no connection, then none of it is going to work anyway. So we're going to keep the while loop there. That's it. Serial port has to work. If it doesn't work, you might have to like close Arduino IDE and then reopen everything again. But yeah, that's it for the setup. Now we can go into our loop function. So we need to initialize some variables. So we're going to have an error to check if it's working or not. And then we're going to have an address, because we need to find the address of the I2C so we can connect to it. Now we're also going to have another one, and it's going to be int, and we're going to call it number of devices. So the reason we're doing that is because when you run it, your MKR can be connected to multiple amount of I2Cs. So let's say you have 5. You need an address for all of them in order for your code to work. So we're going to keep checking how many devices we have. So then we can tell ourselves that we're scanning. So let's print out a line that says that we're scanning. So serial print ln scanning. And then we can we can set the number of devices. Sorry, see, I'm making spelling mistakes, and then my code wouldn't run, and I wouldn't know why. But we're gonna set it to 0, because it's gonna be in a for loop, so it's gonna keep checking. Okay, now we can start the for loop. Bear with me, type it out, and then I will explain what is happening. Ooh, don't do that. So, address, which we already initialized, we'll set it to 1. Then we're going to say, oops, address is less than 127, and then address plus plus. Oop. So if you've coded before, you know how a for loop works. Now, there's technically from 0 to 128 addresses. So there's 129 in total. The reason we're saying address equals 1 and it has to be less than 127 is because the first and last address can't be used. What is it called when like a parking slot is like not available? Like, yeah, it's reserved. Thank you. English isn't my first language. But okay, so we can't use it, so we're not even gonna think about it. Yeah.
Are we allowed to increase the number of bits?
Better not. 9,600 is like the most, yeah, the standard. So no, it works fine. It works fast. Don't worry. Yeah. The address. So we need to find the address of the I2C in order to communicate with it. So that's what we're gonna do in this for loop. Okay, cool. So now we're using the wire library, right? So we want to start the transmission. So let's say wire begin transmission. Make sure you're spelling everything correctly. Transmission. If you spell it correctly, it will like highlight in orange, and that's how you know if you made a spelling mistake. And then address. Okay. And then we're going to say that error will equal to wire dot end transmission. Because if there's an error, transmission, you want it to stop. And we're gonna keep it empty. So this will end the transmission to the peripheral device. Now we can start having if statements to check if there are errors or if there aren't. Technically there is like, so again, I didn't make this code. This is like the standard code to check the address. And for them, they have error 0, meaning that there isn't an error. And if error is 4, that means there is an error. So that's what we're going to use now. So if error is 0, that means if everything is working, we're going to say that we found the device. So serial print, and we can say that the I2C device found at, and then the address. So at address, and we're going to do 0x. The reason it's 0x is because the addresses are in a hexadecimal, so you'll be able to understand what you're looking for easier if this is how you print it. And when we run it, you'll see what's happening. Okay, so If address is less than 16, serial print 0. Because basically, so you get it in the format that will kind of look like this. So this is just like an example. So you can have 0x, 0, and then FF, 12, FE. And this isn't very readable, so you want it to be readable. You want it to be like a number. Usually it's 26 or 27. Cool. So serial print 0. And then after this, you can say, so serial print, and we're going to say, oh, sorry, for the 0, put it in, it's a string. Okay, and then you do serial print, and you're going to do address, and then you're going to type hex because it's a hexadecimal, and this is already an Arduino built-in like thing. So you don't have to worry about it. This is just like the format that it has to be printed in. And then we're going to print serial.print. And this is also going to be a string, and you're just going to do that. So this is just like the basic format that it's being printed in. Now that this is done, we've checked the device that is working. We need to increase the number of devices because there can be multiple. So we do devices plus plus. Cool. So this is the part where error equals 0, which means it's working. Otherwise, so else if error is 4, and now this means that it isn't working. We're going to print out that we have an unknown address. So serial.print, and then ln if you want. ln just gives you a new line, so you don't have to print ln, but you can if you want. And we're going to say unknown error at address. And again, we need to check what address is giving the error, so this is what we're printing out. We're going to print it in the same way, so this Turn off my mic. Oh, that's so upsetting. Stream didn't hear me. Okay, and then how long has it been turned off for? Here, I won't put it on me. So now we're ready to start. Yeah. Oh, it's good. I'll just keep it here. I'm like now scared of it. Although I don't think it was a me problem, but okay. So this is basically connecting to it. But say the first time there was an error. You don't want to just like not try again, right? So we're actually going to make it into a while loop that will keep connecting to it if it doesn't connect from the start. So while the status, so you know how we said that it was idle? So now we're saying if the status does not equal to connected, we're going to keep doing this. So we're going to keep connecting to it. So let's just type it out for ourselves so that when this is happening, we know what's going on. Otherwise, we might be a bit confused. So attempting to connect. Oops. To network. Cool. And now let's print out the print SSID so we know what we're connecting to, because there could be a problem where it doesn't even show what you're connecting to, and then you have to go back to your code, see what's wrong. Because maybe it's a connection that like isn't available, maybe it's private. So we're gonna print it out, and then we're gonna do the same thing that we did. We're gonna connect to it again. And this is gonna be in the while loop, so if it's not connecting, it'll keep going until it's connected. And then we're gonna delay for a bit. So delay, let's say 1,000. Or maybe 10,000. So there's like a few seconds that like where it checks. Cool. Once it's out of this loop, it means we have configured it. So let's say serial.println, and let's type it out. Let's say DNS is configured. Cool. We're done with the setup. Now we can go into the loop. And this is where we're making the request. So let's say serial.println, making a GET request. Okay, and so the client that we are gonna make the request to, like the Twitter username, we're gonna pass it as a string. So you know how when you go on Twitter, you would type twitter.com/ and then the username? So we need to type it as / and then the username. So let's say we want to access the assembly's Twitter page. So it's going to be make smart things. Okay, make smart things. Now we want to read the status code, so to see if it's successful or not. And we want to read the response, so the actual tweet. So let's assign that as well. So let's do int status code, because it's going to come out as a number, equals client dot and then we're going to do the same thing, but this is going to be a string because this is the response. Response equals client dot response body. Okay, cool. Now that we got it, we can print it out so we actually know that we're getting the right thing. If there's errors, we'll find out about them as well. So let's go. This is our status code. And then let's print it out. Serial.println status code. And we're going to do the same thing for the response. So response. And then we can print out the response. Oops. Okay, yeah, I'm spelling it completely wrong. Response. There you go. Okay, this is us accessing the API wrapper. This is us getting the tweet. We've printed it out, but this only prints it out to the serial port. So now we need to make sure that it's actually getting printed out on the LCD. Now we're going to be doing the same thing we've done previously. We're going to initialize it. We're going to do the backlight, lcd.backlight. then lcd.clear, and we're going to set the cursor. Technically, clear should set the cursor to top left corner, but we're going to do it anyway, just in case. Now, okay, so we've got the code printed, but we still need to make sure that the whole tweet gets printed, right? So we need to find a way that we can scroll. There is technically like an auto scroll included in the LCD library, so it's called auto scroll, and we can just call that. And what this does is it moves all the text one space to the left each time a letter is added. But since there is space for 16 characters, we want it to be every 16 characters. So we're going to type out a for loop. Actually, okay, yeah, we're going to do it. That's fine. So let's type it out. For int I equals 0. I is less than the response. Oops. Response length. And then I++. So LCD print, I'm going to print the response dot response character at I. But then we need to make sure that we're waiting until the 16th character before we like move on. So we're going to do if I mod 16 is 0, then we're going to delay it for a bit. So before it scrolls on. Cool. Now we can leave the for loop and we can say that, like, technically not everyone on Twitter posts very often, right? So let's say for this example, we're going to set it to 1 hour. So every 1 hour, it will check their Twitter page. If there's a new post, they will show it. In the end, we can show you how to do it in like for example, if I update it twice in a row, it will update it right away and we'll just change the timing. But for now, let's say we're going to wait for an hour. So serial.println, and we're waiting for an hour. Okay. And then delay. Let's make it 1 hour. It's 1000 times 60 times 60 again. Cool. This is it. And now just make sure your, again, port and board are connected and we can run it. Sorry?
Is it possible to add multiple usernames?
Yeah, not in this code, because the thing is, if you add multiple usernames, how is it going to display all of them, right? So like one username at a time. You will change it. I'll show you how to change it so you can input random usernames at like whatever you want. That's example 7. Okay, cool. So open your serial port. It says DNS configured, making a GET request, 200, and it should start printing for you. The thing is, with this way of, well, there's 2 things that we can improve. First, the way of scrolling we're doing here is it's scrolling horizontally. Yeah, horizontally. So the text comes this way. But then as it comes, you might forget what you just read. So it becomes a bit of a hassle if it's a long tweet. If it's a short message, it's great. Longer one, bit of a problem. Now, the other thing is, you know how we said that we're going to read from Make Smart Things? So we're passing it directly. But what if, say, you want to change the person you're looking at, right? You don't want to keep going into the code and changing it. But what would be nice is being able to input it from serial port. And now we've done this in the previous example. We've inputted stuff from there. So let's adjust the code. So this was example 5. What we're going to do now is example 6, which lets the user enter what username they want from serial port. And then example 7 is improving the scroll. We can make both changes in one go since it's still going to be like one at a time technically.
This one works.
Huh? This example works, but it can still be modified to be better. This is like the simple way of doing it to get an easy auto scroll, but if the message is very long, the auto scroll will get a bit complicated. Yeah, it shows it. So in the serial port, it shows it this way, but then on your LCD, it will actually print it out and scroll through it. Yeah, that's a tweet. Here's a preview of what they'll be doing. So if you open up the twitter.com/make smart things. So let it load. So this is what it has printed out. Here's a preview of what they'll be doing at N5. I'm not sure how Twitter works. I actually don't use it, so I don't know what the most recent one is. I'm assuming it's this based on the way it printed because it hasn't had issues in the past. Because why would we keep checking the Twitter page if no one's posting anything? Technically, it can be a bigger delay. If you know a person, like I know that maybe some person uses Twitter and they post every like 5 minutes. And in that case, you want to be updated, then you would just go here and you would change this to a shorter period of time. No, this is outside of the for loop. It's inside the void loop, yeah, because it keeps checking. You run the code once, every 1 hour, it will check their page and it will update the post that you can see on your LCD. Okay, now we're going to go to example 6. Cool. So the first part will stay the same, but since we want to change it from passing it here all the time, we're going to have a username. So let's go up top before the void setup, and we're going to make a string username. The reason we're doing it up here is because it will have to be accessed in both the void and the loop functions. Now, we also want to keep like a time limit because, for example, if you access the first person, the way we did it now was you tell it what person you want to see. Every 1 hour, they will check that person. In this case, since we're adding like different people, if you add in a new person, you want the time to restart. So we're going to keep a timer kind of running with it. So signed long, oops. Nope, I'm spelling it wrong. Unsigned, there you go. Unsigned long, start time. And we're gonna set the start time to 0. And this will, so the reason it's unsigned long is because it will return, it's what the type millis returns. And millis is what we're going to be using to keep track of the time. So, okay, we've done all the setup for it. We can go down to the bottom of the void setup function. So after we've set the DNS configured, what we're going to do is we're going to say enter a username. So serial.println, and we're going to tell enter a username. So once we do this, I just want to make a note of one thing. You know how we were entering it with a dash make smart things? This is how you're going to have to enter it in serial port. If you just enter make smart things, it will not print anything. So because we're entering it from serial port again, we have to make sure it's available to get our input. So while serial dot available, okay, there you go, is to 0. Oh, so it will keep running. If it's not available, this is where the code ends. We don't need it if it's not available. Otherwise, it's gonna leave this while loop. And so what we did in the previous thing where we had the raw input and then the input that we displayed, we're gonna have to do it here as well because the serial port has a new line. We don't want that extra character to show up. So we can type it once, and then if we need it later on, we'll just copy paste it. If you have your previous code open, you can copy paste it as well. Sorry. Serial dot read string. And then we're going to do username is set to raw.substring. And then we're going to go from 0 to raw.length -1. And now we can just print it out for ourselves so we know we're actually getting the right username. Initializing pager with user, and this is the username. So we're going to do plus username. Yeah.
Since the white code the memory put, right? It keeps checking for the time.
It technically is fine. Like it's not really big deal. It's okay. If it was a bigger program where there was like something that was constantly printing out, then it would be a problem. Like if you're developing a game where it constantly does something and the character is constantly moving in like a circle, that could cause your computer to crash. But this is like, it's a small thing, so it's fine. Okay, cool. So we've done changes to the setup function, but now we have to fix this because we don't want to make smart things anymore. We have a username. So the other thing is, remember how I said we now have to check the time? So we're actually going to put all of this stuff within an if statement. If the start time that we've mentioned previously is 0, or if millis, which we're using for checking the time, minus start time is greater than or equals to, and then this is the 1 hour that we're checking, 1000 times 60 times 60. We will do this. So I'm going to add it as we go. But basically, this is checking if we're starting it or if the amount of time passed has already been greater than 1 hour, and then it will keep doing this. So the things that we've mentioned here, we can just adjust it a bit. This is no longer a string, it's a username. And all of this stuff, we can just copy paste it into here. I like going step by step because then I know I'm not missing anything out. We're gonna enter the LCD screen and this as well. And then here, once we leave that, we're gonna, like, this is still a part of our first if statement. So we're gonna, if the time is at 0 or if it's already been 1 hour, we need to then start the time again, right? So let's start the time. Start time is equal to millis. And then serial.println, we're waiting. Now, the first time you enter a username, you will see that you have an enter username prompt, you enter it. Once you see waiting, that means you can either continue waiting and it will still like read the tweets of that initial user you added, or that means you can already start like writing down new users. So that part is done. But now if it hasn't already been 1 hour, or if we're already like in the process of making it work, this is what we're gonna do. Oh, this is gonna be the same thing that we've written previously. I'm gonna change it a bit, but I don't want to retype the whole thing. So we're gonna have string raw, read string, username, and then instead of this, we're just gonna have start time. Start time equals to 0. Cool. That is it. We can remove the delay since we put it in the if statement. It's no longer needed here. I think I deleted a closing bracket somewhere. Let me just undo that. Yeah, I'm still missing a bracket. Oh, yeah. So sorry. In here, in this else, you need another if statement just to make sure that your serial is available. Serial dot available. And then this is what we're going to keep in the statement. Cool. Now you can verify your code. If serial dot available. Oops. So mine actually disconnected, so I'm just going to re-plug it in. Okay. I think I'll have to re-upload it again. And once you upload it, you can just open Serial Monitor right away because you need to get your messages, whether it's connecting, whether you're able to input a user. Cool. Now you have enter username, and you can type dash and then, oops, make smart things, enter it, and now you see it got it. It's initializing the request, making the request, and here on the GoPro you can see it. It's printing it that way. So here's the preview of what they'll be doing. Now that you have waiting, you can technically put a new username through here as well. Elon Musk, is that his Elon Musk? Ooh, okay, so we have, is that what his tweet is? Okay, interesting. Huh? Okay, cool. So now the one thing that we still kind of want to fix is the scrolling. It would technically be a lot easier if words weren't cut off every time, like there's no more space. So instead, we're gonna kind of make sure that the words get printed one at a time. And instead of going horizontally, we're gonna print it vertically. So it's gonna say like, hello, welcome to the next line assembly. And it's gonna keep scrolling that way. And this was example 6, so you can open example 7 now. Okay. Example 7 will require us, well, there's a few ways to do it, but a lot of them are a bit tedious because you have to keep repeating certain lines. So instead of doing that, we're going to make a different function that we're going to call later. So above a void loop or like, well, anywhere you want, you can actually just make a new function. And this is assuming you have knowledge in C because we're going to be using pointers to kind of make the code more readable. So void next line or clear. And this is either going to give bring you to the next line to print more words, or it's going to clear what you have to bring you to the first line. So we're using liquid crystal. I know we've been going for some time, and I know maybe this is like a bit too much coding, but this is the last example we're doing because this is what gives us brings us to the very end. Okay, so liquid crystal I to C. Int current column. So we have columns and rows, and int current row, and then int clear delay amount. Okay. I know this might seem a bit confusing, but bear with me. Let's just continue together. So current column, we're going to set it to 0. And now we have to check what line we're on. So are we on the first row? Are we on the second row? Because depending on where we are, we're either going to print to the next row or clear it, start from stop. So if the reason we're using pointers is because this has to be accessible through other functions as well. So this is just an easier way of doing that. If current row is set to 1, then we're gonna, oops. we're gonna do LCD and we're gonna point to clear. So we're gonna clear it. Then we're gonna set cursor to 0, 0. Oops. LCD, set cursor to 0, 0. And then we're gonna say that we're gonna change the current row back to the first. So we're gonna go current row is, oops, don't misspell it. Current row is 1. Oh, sorry, 0. So if we're on the second row, we're gonna clear everything. We're gonna set your cursor back to the very first point, and we're gonna set the row to the first one. And then we're gonna delay for a bit, so we actually get time to print everything out. So delay, clear delay amount. Oops. Cool. Now, otherwise, that means we're on the different row. So we're gonna go else, LCD, set cursor to 0, 1, because that means we're on the next line. We're gonna do current row equals to 1. Cool. This is basically the function that we've created. Now there's a few changes that we'll have to make in the loop function. So we're getting the request, we're having the username, this stuff stays the same. But now under the response, we're gonna, okay, I'll type it out and then I'll explain it. Character, PTR, str talk. Character response dot. Okay, so str talk returns a token. Given a pointer to a string and a delimiter, so that's what this is. This is like an empty space. It will return a pointer to the string after this space. So basically what we're doing, we're going to be printing one word at a time and adding a space, so all the words aren't together. And this is why we keep reassigning the pointer, the result of the str talk over and over again until it's null. So we keep reassigning it, and because when it's null, that means there's no more tokens left. So we basically go one word space, and it keeps going back and forth until there's no more words left to print. Okay, we have all of this done, but now before we had this for loop, we can now remove it. We're not using this way of scrolling. Ding. We're gonna add a while loop instead. And there's gonna be a bit of code, but this is the last big chunk that we're working on. So stay with me, guys, stay with me. If you guys are tired, go get some water. We can take a 2-minute break if necessary. So we'll remove the auto scroll. It's not printing. The port is connected. You might have to just close your, save everything, close it, reopen it, reconnect your LCD. Sometimes it just takes, you've done it already and it's still not working. Wait, which one isn't working? Yeah. Okay. Did you take the code from GitHub or were you typing it out? You took it from GitHub? Did it work for other people on that device? So on your table, have you guys tested it out with the MKR and it worked for you? I don't know if maybe. So, okay, possible issues. Either you have to close everything, reopen it, reconnect it. Maybe one of the wires got disconnected. Make sure port and board are connected. Otherwise, it should be fine if it's working for everyone else. Okay, I'm just gonna continue typing because there's a long way to go. So current row, oops. We're gonna set that to 0, and we're gonna do int current column. Is the mic working, by the way? Okay, cool. We're also setting that to 0, so it's starting from the very beginning. Now we're gonna make the while loop, and this is gonna have the pointer that we're using. So while the pointer does not equal null, so while we still have words that we want to try printing, we're gonna go string word equals string ptr. So we're gonna keep checking for the next word. And this basically converts it to like a C character, which then converts to an Arduino string, so it gets printed. So if our word length is equal to 16, oops. So say the word length is 16, right? We need to make sure that it gets printed all together. If the word is more than if it's greater than 16, that means it doesn't fit in one line. And right now what we're doing is we're getting small words and we're trying to fit them all in one line without being cut off. So in the case where the word is bigger than 16, it just, the code would stop working. So we need to find a way to print it going to the next line and keep going to the next line, even if it means the word is breaking. Usually this would be a problem if it's a link, so we need to make sure that the link keeps getting printed without breaking as well. All right, so if it's greater than or equal to 16. Okay, so if this is the case, we want to go to the next line if we're not at the beginning of the line, so we can print it all together. And we're going to do that by going next line order, next line or clear. This is what we're calling from before. LCD and current call. And current row, and then 0. So we're calling that. Now we're going to make a for loop. Okay, so this is like the standard way of making a for loop. I don't think I need to explain that. I is less than the word dot length. And then I plus plus. And now, if I does not equal to 0, so if there's many characters, and I mod 16 just equals to 0, then what we're gonna do is we're gonna, I don't want to retype it because it takes such a long time. I'm going to do this. Next line, LCD, current row. Cool. And then we're going to make sure that we're printing the words or the characters. So LCD, print word dot character at the character that we're looking at. Cool. So otherwise, we're actually going to be printing the normal words. This was the full if while what? Wait. So here's where the if statement ends. After the if statement, just make sure you, there you go. This is why. If next line block. So this should be after it. I didn't close it. Now here's the else. All of this should be in the while loop. Make sure your brackets are closed correctly. Okay, I'm gonna type it out first and I'm gonna explain it because it might take a bit of time. So current column does not equal to 1. Sorry, does not equal to 0. Then we're gonna do lcd.print. We're just gonna print an empty character. So this is gonna be like our space. And then we're gonna increase the current column by 1 plus equal to 1. Because then we want to move forward from the space, right? So we print a word, we have the space, we move on to print the other words. Now, this is the first if statement. This computer doesn't like auto fix it for you. So like if you leave a space, it doesn't go back. It's a bit frustrating. Not like using VS Code. Okay, so if the current column plus the word length is greater than or equal to 16, whoops. Then we're going to print out the thing we printed out previously. And then we're going to continue. Continue. Else, we're going to say current column by current column plus equals word. Hi. Oh yeah, we 3D printed a case. I'll show you guys in the end. 3D printed. It's a 3D printed case that holds the LCD, so you can kind of set it and you can have it for you. Yeah, it could have been a bigger case, so you can actually solder the wires onto the MKR and then keep it like in a box. But we didn't want to do it for today, so people can actually use the MKRs. Okay. Okay, we're almost done typing, so I'm just gonna continue. So plus equal to word.length. It'll be so sad that in the end, like if in the end there's an error, because there's so much going on here. So print. Although this is technically like the more clean way of doing it, because if you don't have the initial function that we were typing out, you would have to keep like checking the line that you're on, and you'd have to go back and forth, and it makes the code very, very messy. Okay, and so then we're creating the next part. So we're doing PTR equals str talk, which still kind of, okay, right? We're gonna, this is the empty and delay. Okay, cool. We have done it. I don't think there's anything else you have to change. Oh, no, you do. Oh, no, you don't. Because the start list is still here. So basically what happens is after this, what we just typed out, the rest of it is the same because we're still checking if there's another user that you're inputting like as you go. So technically, and I'm hoping it works from the first time, but you know there's a coding thing where it says if it works from the first time, there is like a bigger issue, like something is wrong. Okay, done uploading. Let's open serial port. Okay, enter a username. So make smart things. This time, here is what's happening. It's printing one word at a time, and it's scrolling down. So it prints it, and it keeps going. And now, it says waiting, so we can do make code simple. Make code simple is another account that assembly uses, usually used for like this kind of stuff. So like yesterday we were posting stuff just to see like if we decrease the amount of delay, if it will like keep printing new things. So let's make code simple. Making a get request. See you at in5 this Saturday. So again, it's printing out see you at in5 this Saturday. Now, well, that's it. We have fixed the scrolling. We have fixed user input for the Twitter, and that was the last example that we're working on. So we have concluded it. We have our device. Technically what we did, so I wanted to mention it at the start, but I think it's fine to do it now. We printed a 3D case for it, so it holds the LCD in it. You have the wires, we've soldered them in. It would be a lot nicer if this was soldered as well to the MKR, but for testing purposes, we didn't want to do that. We needed all the MKRs we could get. But this is, like, you can just keep this at your desk, and it can just keep running, and you can keep track of whatever Twitter celebrity you like, and you can just get their tweets. If you decrease the amount of delay, if you know the person is posting frequently, you'll get all of their tweets constantly showing up. So yeah, that is it. You guys can check us out on social media accounts. This was the first workshop that I was hosting, so hope you guys enjoyed. But yeah, that's it. Thank you so much. I hope you guys enjoyed. If you want to see how it worked, you can again go to the YouTube channel. We have this live streamed. That's it. Thank you guys so much. I will reconnect. You don't have to stop it. I want to reconnect it. Thank you. I appreciate that. I just want to, if you put the GoPro view, I want to show how you would connect it to this. So we start with ground. We do SCL, and then we do SDA, and then you connect power. It is now working. So we can run this again. Okay, done uploading. You can open it up. Technically better to clear it, but I didn't clear it, so it's fine. So make smart things. Or actually, okay, let's do make code simple, just because I was using it yesterday. I was like posting stuff on it. That's really cool. So getting a request. See you at in5. And then it just shows that way. It's pretty simple. You can take pictures of it. If you guys have Twitter channels and you want to run something, we can post it. We can check out your tweets. Do you guys have a Twitter channel? Do you want to post something and we can read about it? No, emojis won't show. They'll print as like random characters. I'm assuming there's a way to solve it, but not quite sure. Ah, if you do that, it'll work. Yeah. Those kind of emojis will work. The original ones. Cool. I think that's it. Yep. Guys, so that's it for today. We have workshops every Saturday, so you're always welcome to come in. We post about them on our meetup page. So if you go meetup, the assembly, or make smart things, you'll find